Left alone, heat always flows from warm to cold. So the inside of a fridge, by itself, slowly warms up from the heat of the room. To keep it cold, you must move heat the other way, out of the inside, into the room. That takes work. Doing that work is a refrigerant flowing around 4 parts: compressor, condenser, expansion valve, evaporator. The refrigerant circulates around and around. The compressor squeezes the low-pressure refrigerant gas, raising its pressure and temperature fast. The hot gas goes to the condenser, outside. There it dumps heat to the room and turns back to liquid. Through the expansion valve the pressure drops, and the liquid suddenly gets very cold. The cold refrigerant enters the evaporator, inside. There it absorbs heat and boils back into a gas. Here is the heart of it. When the refrigerant evaporates at low pressure, that is, boils, it pulls heat from its surroundings. That is what makes the inside cold. A fridge does not make cold. It carries the heat from the inside out to the room. The thing that carries the heat is this phase change. Evaporation absorbs heat, condensation releases it, and the amount is set by the latent heat. The dot on the diagram is the refrigerant state, looping through 4 steps: compress, reject heat, expand, absorb heat. The heat it moves is far larger than the electrical work you put in. That ratio is the coefficient of performance. It is usually around 3, well above 1, so it beats a heater by far. Run the same machine the other way and it pumps heat from outside into the room, heating the house. That is a heat pump. An air conditioner, a heat pump, and a fridge are all the same machine. A machine that moves heat. NovaSolver. Physics made visible.